Hi, Dan here. Welcome to Fun Kids Science Weekly Reach for the Sky Special, the podcast that explores the future of aviation, from the design and sustainability of future planes to the people who keep them flying and make sure our experience is top-notch. Did you know that the UK's airspace is one of the busiest in Europe, handling around 7,000 aircraft flights each day? That's aircraft taking off and landing at UK airports, as well as planes flying through our airspace, say from Europe over to America. In this podcast, we'll meet the Civil Aviation Authority. They're the UK's specialist aviation regulator, responsible to make sure flying is safe for everyone. They're like the safety police for airplanes, airports and pilots. As well as regulating the economic aspects of aviation, they're also involved in shaping the future of flight by supporting the development and integration of new aviation technologies, including electric and autonomous aircraft, drones, as well as future aviation fuels too, particularly hydrogen, as part of its commitment to environmental sustainability and the UK government's Jet Zero strategy. To start us off, here's Amy Aviation to give us an insight into the sustainability of aviation, from the materials used to make planes to the fuels that power the engines, as well as what you can do with an old plane when it's not flying anymore.
Amy Aviation, reaching for the sky.
Hi, Amy Aviation here. Today, Zac and I are landing in a very different kind of adventure. Because we're not taking off, we're getting down to Earth, talking about how aviation can play its part to reduce environmental impacts on the planet. That's right, we're flying into sustainability.
And decarbonisation.
Sustainability? Decarbonisation? What do all these big words mean? Well, right now, planes create about 2.5% of global carbon emissions. So engineers and scientists are on a mission to build smarter, more efficient aircraft that have less impact on our environment. So where do we start?
Fuels of the future!
Let's talk power. For many years, planes have used aviation fuel, which is a carefully refined, light petroleum that can withstand extreme temperatures. More recently, there have been developments with sustainable aviation fuels that aren't made from fossil fuels, but things like algae and biomass, and even used cooking oil.
I guess batteries can also help.
Correct. It's likely in the near future, small electric planes will be common for flights up to 500 miles. But you need small, relatively lightweight batteries with a lot of power, ideally sustainably sourced. There's also another fuel in the mix, and that's hydrogen. Instead of belching out CO2, hydrogen-powered planes would only leave behind water vapour. Cool, right? Airbus, one of the world's biggest aircraft manufacturers, is developing its Zero-E project, looking at building planes using hydrogen fuel cells instead of jet fuel.
So future planes will be more sustainable. But does it end there?
Magic materials.
No, the stuff planes are made from is changing. Smart new designs means we're building planes with sustainability in mind. That's making materials easier to trace, repair and recycle. Heavy metals are being swapped for lightweight, super strong new materials. And fancy new plastics called thermoplastics that are strong, light and easy to recycle might be used for the airframes. Even biofibres from things like algae are being turned into aircraft parts. Plane manufacturers are working hard to make sure parts of a plane can be built using materials that can be reused instead of wasted. That way, when planes retire, they can be taken apart and turned into something new. And the job doesn't stop once an aircraft touches down for the last time. That's when we can start reusing and recycling all those materials.
Recycling planes? You'll need an enormous recycling bin for that.
It's definitely a challenge. With about 15,000 aircraft retiring over the next 2 decades, we need to find smart, eco-friendly ways to say goodbye to our flying friends. And that's where special aircraft recycling centres come into play. Old planes are being carefully decommissioned. First up, any useful parts are removed. Things like engines, landing gear and electronics. They're inspected, fixed and then sold on to fly again.
So it's like a plane parts spa day. You'll come out as good as new.
That's right. And by reusing parts instead of buying new ones, we're saving money and the planet. Once all the parts are out, the aircraft can be taken apart piece by piece. Everything from the hydraulic systems to the fuselage.
Fuselage? Sounds like a fancy pasta.
It's the main body of the aircraft. Most aircraft bodies are made of aluminium, steel and titanium. And guess what? They can all be recycled. In fact, over 90% of an aircraft's weight can be reused or recycled, and even fittings like seats and windows can be repurposed for cool furniture for our homes, and even used to make shoes. That's all thanks to specialists like dismantlers, recyclers, and maintenance crews who work together to make sure nothing goes to waste.
It's the ultimate team-up. Avengers, disassemble.
We also need to remember, it's not just planes. Airports can also be more sustainable by using renewable energy for airport operations, whether powering terminals or ground equipment like electric airplane tugs and baggage loaders. It's all part of reduce, reuse and recycle, aviation style, and it's not just for the environment, it saves money too. Next time you see a plane soaring overhead, just think, one day you might be wearing part of it.
Amy Aviation. Reaching for the Sky. Created with support from a CAA Reach for the Sky Challenge grant. Find out more at funkidslive.com/Amy.
Thanks, Amy. We might just see the captain and crew, but it's crazy to think that hundreds or even thousands of people have put in the hours to get us off the runway. And one of those people is Helen Leadbetter, who works for the Civil Aviation Authority as the Zero Emissions Flight and Hydrogen Challenge lead. I met up with her so she could tell me more about the work she and the CAA do to prepare for a greener future. So let's chat. Here's Helen Leadbetter from the Civil Aviation Authority.
I work for the UK Civil Aviation Authority as a technical strategy lead for zero emission flight. And what makes this really exciting is that we have the opportunity to shape what aviation looks like in the future. We look at new fuels, specifically hydrogen, and we're looking at how we can use hydrogen as a fuel source to decarbonize aviation and enable aviation access to everyone.
And then what would that look like on a weekly basis, Helen? What's the day-to-day?
So on a day-to-day basis, I speak a lot with industry. So our industry includes organizations such as Airbus, who fly large-scale aircraft, down to very small innovators, with companies such as Zero Avia, who are retrofitting small aircraft with hydrogen fuel cells. We also work with airports to look at how an airport would operate a hydrogen-fueled aircraft. And then we work with hydrogen producers to understand how they produce the hydrogen and how they're going to get the hydrogen to the airport to enable the aircraft to be refueled.
And what would you say is the most exciting part of your job?
I think the most exciting part is meeting the innovators that are making these new technologies and understanding how these aircraft can fly safely and operate safely, and that we are also enabling decarbonisation of industry.
Plane engines have been jet fuel based for many years. To be more sustainable, I guess that it's important to develop new types of fuel to power our future planes, right? And that hydrogen is an option.
So hydrogen as a current fuel for aircraft differs because of its wide flammability range. So that means it can catch fire much quickly than current, what we call Jet A1 fuel types. It as a gas, it's one of the lightest elements, so it escapes. So we call it a very leaky fuel type. So it can leak through metals and small gaps, and we have to look at ways of restricting that. We also need to understand how we can make, by volume, hydrogen is much bigger in volume than kerosene-based fuels. So it takes up much more volume when it's fueled into an aircraft. So we have to look at how we move from traditional refueling, which is refueling aircraft via their wing tanks, and how we're going to move their wing tanks. We're going to move them then into the body of the aircraft, so into the fuselage. And we look at how we're going to compress gas or use liquid hydrogen to enable aircraft to fly further using hydrogen. And the reason hydrogen is being looked at as an alternative fuel source is because it doesn't produce any CO2 emissions.
Whoa, that's amazing, isn't it? So we're looking at a fuel without any CO2 emissions. Incredible to think of the positive impact that could have on the planet, right?
It's seen as a key enabler to decarbonising aviation, and aviation is seen as a hard sector to decarbonise.
I suppose whilst it's easy to have batteries in small vehicles like cars and drones, a large rack of batteries isn't that practical on a plane. Is that why there's a focus on hydrogen?
Batteries are not at a technology readiness level that enables us to fly our 10 or 12-hour flights. The same as with ammonia. To have that on an aircraft is too complicated because it produces another emission, which is NOx, so nitrous oxide, which is considered harmful as well. So we're looking at using fuel sources that are not putting any other emissions into the atmosphere. So for hydrogen, it's basically water that is that emission.
What are the challenges that are faced, and what's the time frame that you're looking at, Helen?
So it varies. So some of the challenges are around whether industry want to use gaseous hydrogen or liquid hydrogen. So gaseous hydrogen comes with its own set of challenges, which is how do you put it into a small confined space of an aircraft. So how much can you compress that gas before you need to move to liquid hydrogen? The problem with liquid hydrogen is you need a whole cryogenic system that goes with it.
That's keeping it at a cool temperature and the right pressure to keep it liquid instead of gas, right?
And that technology is at really low research levels at the moment. So a whole refueling system needs to be created around that. We also need to look at actually producing hydrogen. So in the UK, we produce very little hydrogen ourselves. So how do we enable green hydrogen specifically to be available? So anything made from solar or wind power to create the hydrogen, rather than relying on it, importing it from Europe. Those are kind of some of the main challenges, and the timeframes vary quite significantly depending on the type of aircraft you're looking at. If you're looking like a little small 9-seater aircraft, we have Zero Avia that currently flies a hybrid option, which is one engine that is hydrogen fuel cell and another which is a conventional engine. So that flies under what we call a permit to fly. So it's a test aircraft. And they want to be flying commercially with people on board, like paying public, in 2028.
So it might be something in use on smaller planes sooner than the larger planes that we might go on holiday on.
If you're looking at something such as Airbus and an A320 sized aircraft that carries 100 people or more, they're not looking at before 2040 now as an entry into service date for that type of aircraft. Originally it was 2035, but they've pushed back on that and said now 2040.
You work for the Civil Aviation Authority. Can you just explain what that is?
Certainly. So the Civil Aviation Authority is the UK aviation regulator. So we are here to ensure the safe operation of aircraft. So that's not just looking at the aircraft itself. We look at the people that use it, but also the people that live around airports. So anywhere that aviation has an impact on the general public, we have a remit to ensure that that is safe.
So along with future fuels, safety really is at the heart of what you do today, isn't it?
So we will certify aircraft to make sure they're safe to fly. We'll license and certify airfields to make sure that they're following and complying with regulatory requirements. We have joint responsibilities with the Health and Safety Executive, which is another regulator, to ensure that the fuel supply is correct and is fit for purpose for going on aircraft. So our remit is ensuring the safety of aviation.
So you said what you can do is regulate. Is there anything you can't do?
So we don't get involved in things like the business models and things like that. So we're not there to say whether something is commercially viable, shall we say. We're only interested in whether it's safe to fly or not. So we're not interested in whether it makes money, whether people can make a profit from that. We're only interested in how it flies, operates safely. We're also not there to tell people how to design their aircrafts. They'll propose a design to us and they have to prove to us that it's safe to operate. We never lead people down a design pathway. That's not within our remit.
Will the people designing the planes ask you for advice in terms of how you would regulate that?
Something we're doing with hydrogen at the moment is looking at a certification pathway for hydrogen aircraft. So we're asked a lot of questions from industry to say, I don't know, we're going to be using a hydrogen fuel cell. If we want to use your current certification specifications to certify this aircraft, there are gaps in those regulations that don't apply to hydrogen. So they're saying, how do they fill those gaps? So they're asking us that question. So we work with them to understand what those gaps are, and then how are they as an industry proposing to fill them. And then we look at kind of their test data to understand whether that then falls into what we call a special condition that enables them to go away and test that and see if it operates safely.
And although I understand that air traffic control is a separate part of aviation management, you guys are contributing to how it might look in the future, aren't you?
So we're just doing a whole airspace modernisation piece, and we have a team that's working specifically on that to understand how airspace can be designed better to accommodate different types of air traffic. So at the moment we have what we call conventional aircraft, which is our passenger carrying aircraft. We then have general aviation, but we're also now starting to see things like drones. And so how do we safely integrate that into our existing airspace? It's looking at the whole ecosystem and how it all fits together.
Okay, interesting. But your focus is particularly on these future fuels that we've been learning about. So maybe let's get back to the big question. Why is it important to develop new types of fuel, such as energy to power planes?
So the reason we are looking at new fuel types is basically a government request. They have put into law, and I think it's in the Climate Act, that it states that aviation needs to be net zero by 2050 for all aviation, and by 2040 but for UK aviation, so domestic and regional flights. So we work with industry to support them in achieving that goal by government, because it's written into law. It means we have to assist industry within this work that they're trying to do to have a pathway to enable that.
And you've said this isn't just about saying, yes, you can use hydrogen now. It means that you've got to think about all sorts of factors, right down to the design of the planes. So when you're designing a plane, how will the design differ now with hydrogen as its main fuel source?
So with hydrogen, because of the volume of it, we have to move the fuel tanks. So no longer can we have the fuel tanks in the wings. They've got to go in the aft compartment of an aircraft. So at the moment, industry is looking at what we call retrofitting. So it's taking an existing airframe and moving the tanks. And so you end up losing passenger seats. So you'd have the same size aircraft, but it'd be much heavier and with less passengers on it. And then we have the option where industry look at what they call a clean sheet design, which is they design the aircraft from scratch around a hydrogen fuel system and all of its requirements, which initially on paper has been looked at that the fuselage might be wider, but it might be shorter. It might need longer wings, so what we call a dry wing. So you'll have no fuel tanks in there, so you can get some maybe aerodynamic gains from having what they call a dry wing. So the center of gravity of the aircraft will also change now. It'll become what we call a tail-heavy aircraft. At the moment, with the current fueling that we use, we're limited on maximum takeoff weight. But it's more likely with hydrogen we're going to be limited on maximum landing weight because the hydrogen is so light already. You're not losing lots of kilos as the fuel is burnt, which we currently do with kerosene. There's quite a few factors there, and also airports are looking at how do they design to have different fuels on site, because we're not just going to switch overnight from kerosene to hydrogen. You're going to have lots of different fuel types at an airport. So how do they incorporate all those fuel types within an existing airport? Because airports have restrictions on how they can expand. So how do they introduce hydrogen at an airport to enable different types of aircraft to operate? So you could have hydrogen, battery electric, you could have still aircraft flying on SAF, on Jet A1. So an airport, I think they've got a bigger challenge of how do they have all these fuel sources on one site in the same footprint of area that they currently have.
So, lots to think about. But with the aim of less pollution, that's got to be a good thing. I suppose another question is, how is this going to impact the flight of the planes for us passengers? I mean, will it make it slower or faster?
We don't know yet. I think the way that manufacturers are looking to design it is that they would have some what they call top level requirements, which is that they need to be able to fly at the same speed and get to their destinations within a similar time frame. So I think they're designing to enable similar performance if they can. I still think they're quite early on in that to understand the full impact of it, but they do get that they might not be able to fly as far. So where we're quite used to having, I don't know, now I think some of the Boeing aircrafts and Airbus flights can do 16 hours as the total in one flight. We might have to go back to that. We'd have to stop somewhere and refuel before going on again. So it might be that we go back to what we call a hopper flight, where you have to do a stopping and a refueling requirement.
So it might take us a little longer to reach our destination, right? And there's lots to think about in the wider use of greener fuels, isn't there? After all, there may have fewer emissions once in the sky, but making them might not actually be as simple.
So sustainable aviation fuels, although they reduce emissions, my understanding is that they are not net zero, or they're not zero emissions, shall we say. So they're still creating emissions, and the way they're created is through things like feedstock or waste food products. So it's when do you get to a point where are you diverting food from the food chain to go to making fuels rather than feeding people? That's quite controversial. So there is kind of, I think it's understanding how, if we continue down the sustainable aviation fuels route, is where do you get those byproducts that are needed to create that fuel?
So we've talked about hydrogen, but there are other future fuels. Can you tell us a bit more about the future use of batteries to power our planes? You said they're a bit farther off in terms of the workable tech.
Batteries, in theory, it would be the ideal solution. They're just very heavy at the moment. So by the time you put batteries on, let's say, a 9-seater aircraft that's needed to operate for, I don't know, let's say a half an hour flight, you're probably at your maximum takeoff weight already. So you wouldn't be able to put passengers or cargo on it. So at the moment, batteries are really restricted by their weight. And also, not just their weight, it's also if you wanted to fly for more than 30 minutes, that their flight duration is not. If we want to do a 6-hour flight with batteries, that's not currently possible.
Yeah, you'd probably need a pretty big battery for that. What about something like nuclear power? Could that be an option?
Yes, it hasn't come to us from industry. It's on what we call our horizon map. So it's been mentioned. I think it's fusion that's been mentioned. But we haven't had any requests from industry about that. I've spoken to I think they're called the Nuclear and Atomic Agency, and they said that they've only seen kind of people looking at it from a ground-based infrastructure point of view, which is around 2040, and looking how nuclear power could be used to provide more power to airports, or for making things like hydrogen and that refueling process, which requires a lot of electricity. I think it's something that needs to go out to maybe industry to say, is it something you're looking at? And then from there, we always take our direction from industry. So if industry say to us they're going to be looking at nuclear, then we'd pick it up and go away and then start researching it to understand what implications that has and how they are looking to design that type of aircraft.
Okay, so we've been zooming in on the people behind the plane power, and it's been really cool to hear about the kinds of things that your job involves. If you had to choose, what's one of the coolest things that you've done while working in aviation?
So we did a big ground demonstration with Exeter Airport on hydrogen ground support equipment. So at an airport, when an aircraft arrives, we have lots of equipment that helps to offload the baggage, push back the aircraft on departure, give the aircraft power while it's sitting on the ground. We did a big demonstration down at Exeter using a ground power unit, a pushback tractor, and a baggage cart that was all fueled by hydrogen. Yeah, zero carbon emission turn. So yeah, we had no fossil fuels used on the turnaround of that aircraft.
Oh, that's so cool. Next question. What's your favourite airplane?
My favourite airplane is the old 747s.
Why a 747 rather than a newer design?
Because it was the first one I ever flew on as a kid and I loved it.
And if you were going to design a plane of the future, what would you make sure it had or could do?
Oh, I'd want it to fly supersonic so that you could get everywhere quicker, although that's not seen as a good thing for sustainable aviation. And I'd want it to be, I would actually like it to be a hydrogen-based or a fuel source that doesn't create any emissions, so that wherever you're going in the world, you're not making an impact on it. I think the problem with Concorde is it was very expensive for people to fly on it and to operate. So you need to get that balance where we want aviation to be accessible to everyone, not just a minority. So it's how do you take new technology and make it accessible for everyone, or even to the point whereas you enable people to make an informed choice that they can choose. I don't know, it might be £50 more expensive to fly on a zero carbon aircraft, but they would have that opportunity to choose whether they wanted to or not.
Thinking about your career, was there any telltale signs growing up as a kid that you would have a career in aviation?
Yes, I think my parents and grandparents always took us to air shows and things, so I always had a keen interest in aircraft. So it's something I really enjoyed.
And what about at school? What did you do there? Were there any subjects you liked that helped guide you into this career?
I love geography, so I always wanted to work in an industry where I could travel. So aviation was the one that enabled that for me.
And do you get a lot of opportunity to travel for the work you do now?
Yes, I do. I travel a lot in the UK, but I've just come back from ICAO, which is the International Civil Aviation Organisation. I've been there to present our hydrogen works. I went to Montreal to do that. I've been to a few things in Europe. So yeah, it's not... I travelled more when I worked at airlines, but yeah, within this we do get some scope to travel, especially if we're working with other regulators. So we work quite closely with the Federal Aviation Authority from the US and with EASA, so the European Safety Authority as well. So from time to time we would attend meetings with them, and they might be in Cologne, which is EASA's base, or in the US at one of the FAA bases. So yeah, we do get to travel.
And then, what words of guidance would you give to children considering a career in aviation? You didn't come through the uni route, did you, right? But we've been finding out that there are a ton of different ways to be part of the aviation world.
I would say try everything, because you never know where you're going to end up. I come into this in a very unconventional route. I didn't go to uni. I didn't study engineering. Yeah, I've ended up working on new technologies and how to certify them. So yeah, don't always look at the conventional routes into an industry. And even if you haven't worked in it, still give it a go, because you have transferable skills.
So you say it wasn't the conventional route. Could you just explain what your route actually was?
Yeah, so I did after leaving school. So I did my A-levels, but I did them in geography and leisure and tourism. So I knew I wanted to work in that kind of sector. And then I applied for an apprenticeship. So I did an apprenticeship with an airline. So I got to work in all departments. I worked in cargo, engineering, ground operations, and their kind of like head office. And at the end of we did 6 months rotations in each department, and at the end of that you got to choose a department to go and work in. So I chose ground operations. So I worked on check-in and on the aircraft turnaround, and then from that I got the opportunity to move into doing flight operations. So I used to do flight planning. Then I moved back out to manage the whole operation at Heathrow. Then I travelled. I got to go and teach people. So I travelled across Europe, Middle East, North America to teach people about aviation.
So apprenticeships sound like an amazing way to learn whilst working. And if that sounds like something you'd be interested in, here are the deets. Did you know there are loads of aviation apprenticeships in the UK? And you don't need to have a pilot's licence to get a career off the ground. You could train as an aircraft engineer, air traffic controller, cabin crew, cybersecurity whiz, or even work in aircraft operations, from ground crew to the apron, or get technical in aerospace design. Some apprenticeships are perfect if you've just done your GCSEs, while others might need A-levels or even a degree. You'll find them through further education colleges, big aviation companies, and even your local airport's job pages. Whether you dream of fixing planes or flying them, there's a sky-high start waiting for you. So, back to you, Helen. It sounds like an apprenticeship really opened up the door to the world, even after having to change roles. Can you tell us a bit more about how you arrived in the heady world of hydrogen?
I got made redundant during COVID, and I applied for a really random job role that just said, we want an aviation airline specialist, and I applied for it, and on the first day of work I turned up and they said, we're going to be researching hydrogen aviation, and I was like, oh, I think you got the wrong person because I know nothing about it. And they're like, no, it's a brand new project. Government want us to look at how we can do zero emission flight. So I worked with 100 people from different aviation backgrounds for a year program researching zero emission flight. And from that, it turned out that hydrogen was probably the better option for aircraft to decarbonize. So from that, I then moved to the CAA to work in their innovation team, looking at hydrogen propulsion systems. So like I say, I don't have a engineering degree, but I've learned as I've gone along, and you can always pick up skills through attending courses that are run by various organizations. You can do on-job training. There's lots of different routes into it, because I get university is not for everyone.
And then the last one is in 10 years' time. Where do you see yourself?
In 10 years' time, I would like to see myself managing a program of certifying not just hydrogen aircrafts, but zero emissions aircraft across all what I call technology platforms. So that's having hydrogen drones, hydrogen helicopters, aircrafts, and then ensuring that they're accessible to everyone to fly on.
Thanks, Helen. And with all that, it's time for us to head to departures. I hope you can join us again soon. Fun Kids Science Weekly Reach for the Sky special, created with support from a CAA Reach for the Sky Challenge grant. Find out more at funkidslive.com.